All right. Um, any questions? Anybody got any questions? Huh? Good. So we'll talk after class. Okay, yeah. But any material questions anybody got? All right. So I want to talk to you guys about something. I made a mistake. So I just want to let y'all know what happened. So sometime in like March, like early March, I had gave y'all a homework, but I never taught y'all how to do the homework. So that lesson for that homework I'm going to teach y'all today. All right. Sorry about that. After today, you should be able to complete all your homework in its totality. All right. Huh? Fast. Yeah, yeah. So like it's like I gave you the homework, I didn't show you how to do it. So now I want to show you how to do it. Now, some of you probably like went to tutoring and did the homework already and all of this. Just kind of bear with me today, you know? All right, so this is what we're getting into. Solving linear inequalities in one variable. All right. So a linear inequality, as its name implies, is an inequality in which the only operation involving the variables are addition, subtraction, and multiplication by a constant, of course. In this section, we're going to consider inequalities with just one variable. Like equations, inequalities can be true or false. All right. Solving an inequality involves finding all values for the variables which make the statement true. A look at a very easy example of a linear inequality shows a significant difference compared to linear equations. Consider, for example, the linear inequality x is less than or equal to 2, right? Notice that the variable, everything good? Mhm. So notice that the variable is by itself on one side of the inequality with no other operations involved. We can see by inspection that 2 is a solution because 2 is less than or equal to 2, right? That's true. Notice that x less than or equal to 2 is a compound statement. It is true when either x is less than 2, it is true, or when x is equal to 2 is true. But 2 is not the only solution. For example, 1 is also a solution, right? 1 is less than or equal to 2. That's true. -4 is another solution. -4 is less than or equal to 2, which is also true. 1.99999999 is another solution, right? Because 1.999999 is less than or equal to 2 is true. You can convince yourself pretty quickly that the very simple linear inequality x less than or equal to 2, in fact, has infinitely many solutions. This is a typical algebraic inequality. All right. Yeah. Can you hear it? Make sure you kind of tall, so make sure that it's on 60 up there. I can't see because the light is blocking my view, so I can't see. But if it says it's 60, then it's working. Yeah. I turn them all on in every single classroom, so yeah. It's 60? All right, so we good then. This joint working over here a little bit. But I gotta stick with this light. Mhm. But I feel you though, it's mad hot. Like the computer over here is saying 89 degrees right now. You know? Yeah. Yeah. All right. Most linear equations in one variable have exactly one solution. We have seen at least one situation where a linear equation might have infinitely many solutions, but in that case, every real number is a solution. The easy inequality we are considering is x less than or equal to 2 has infinitely many solutions, but not every real number is a solution. For example, 3 is not a solution because 3 is not less than or equal to 2, right? That's a false statement. All right. So Kevon, what I was saying when you had left, I had accidentally posted this homework like way too early, like in the beginning of March. So you already have the homework for the lesson I'm going over. So if you want, you could just kick back and knock out the homework while I'm talking, if you want. You might have finished it already. If that's the case, I'm sorry I didn't get to show you this earlier. Huh? I don't remember the number, but it's an inequality homework. It says inequalities. Yeah. That's my fault, man. All I could tell you was like early March. Like that's the date that it was posted. But you might have finished the work on it already. And if that's the case, it's okay. No problem. So man. All right, so even the simplest linear inequality poses the following questions for us. How can we solve the inequality, find all the solutions when there are infinitely many of them, right? How can we indicate which numbers are solutions and which are not? To answer these questions, we will introduce a technique that will be useful in a number of situations, graphing. All right. So to graph an algebraic statement means to draw a picture of all the solutions. Typically, our picture will involve our standard method of visualizing the real numbers, the number line. So solving and graphing are really the same type of problem, finding all the solutions, but the answer is written differently. All right. All right. So our basic method for graphing algebraic statements will be to indicate solutions on a number line with a solid circle, right? So a solid dot. In the case that we have many solutions infinitesimally close to each other, which will look like a solid shaded line, here's a simple example we have considering so far. So graph the solutions of the inequality x is less than or equal to 2. All right, so check this out, check this out, check this out, check this out. All I'm gonna do is I'm gonna make a number line. All right. You guys remember the number line, right? In the middle, just to make my life easy, I'm gonna just write down 2. There it is. That's 2. So to the right of 2, you're gonna have some increase in numbers, right? So here goes 3, here goes 4, here goes 5. You get the idea, right? It's gonna just keep going on, right? To the left of 2, we're gonna have decreasing numbers, right? So here goes 1, here goes 0, here goes -1. Here goes -2. Again, you get the idea, right? It's going down, right? So if I'm going to graph this inequality, right, there's two ways you could do it. You could do a solid circle like this, and then you just shade the numbers that you're considering, right? So x less than or equal to 2, so you're shading all the numbers that are smaller. That's one way to do it. Another way you could do it, I kind of like this way a little bit more. Instead of the shaded circle, maybe you write a bracket, right? To indicate that 2 is part of the solution set. It's all the numbers that are smaller than 2, including 2, right? X is less than or equal to 2. All right. Any questions on this? All right. Y'all probably know how to do it all already, which is fine. I'm not mad at all. Let's talk a little bit more. All right. So in the graphical method for solving linear inequalities, special attention must be given to the border value, right? Consider, for example, the strict inequality x is greater than -3. In this case, any number to the right of -3 on the number line will be a solution. the border value, -3, is not a solution. However, -3 greater than -3 is false, right? In order to deal with the problem of shading every value to the right of -3, but not including -3 itself, we will indicate the border value with an empty circle, like O or whatever, right? So let me show y'all what I mean. Now I'm gonna make this real pretty too. Real pretty, real pretty. All right. So the graph of all the solutions of x is greater than -3 is this, right? We have -3 in the center, right? We're going to shade all the numbers to the right of -3, right? Because we're including all of that, right? But notice at -3, this is an open circle because -3 is not part of our solution, right? It's all the numbers that are small, excuse me, that are bigger than -3, right? Another way to do this also, if you didn't want to do the open circle, would be to have an open parentheses, right? That also means the same thing, that I'm talking about all the numbers bigger than -3, but not including -3. All right. Yeah. The open circle and the parenthesis means the same, right? The closed circle and the bracket means the same, right? So closed circle and bracket are the same. Open circle and parentheses is the same. Okay. So border values for linear inequalities in one variable. For strict inequalities, greater than, less than, the border value is indicated with an open circle, right? Because it's not included. For non-strict inequalities, less than or equal to, greater than or equal to, the border value is indicated with a solid circle, right? Because those numbers are included. Okay. In order to solve more complicated linear inequalities in one variable, we present two slightly different methods. Each has some advantages. Both will rely on the methods we have already developed to solve linear equations in one variable, namely the addition and multiplication principles. The main difference between the two methods will be deciding which side of the border value to shade. All right. All right. So next we're going to be talking about solving linear inequalities in one variable, the test value method. All right. So now we're getting into the a little bit of calculus right here. All right. I know y'all all changing over to a math major at the end of this, right? Definitely. So as the above simple example show, right? Graphing an inequality has two key steps: finding the border value and deciding which side of the border value are solutions to the inequality. Our first method of solving inequalities separates these two steps. The main idea is this method is that, in this method, excuse me, is that the border value of a linear inequality divides the number line into a greater than side and a less than side relative to the inequality. The border value corresponds to the solution of an equation. We will determine the appropriate side to shade by choosing a test value, which will determine which side is which. All right. So here's an example. Graph all the solutions of the inequality 3 times x plus 2 minus 4 is greater than 2x plus 8. All you got to do, put all your x's on one side, put all your numbers on the other. That's it. And then you just graph the answer. Let's take a look. Let's try this out. So just to recap, right? I got 3 times x plus 2 minus 4 is greater than 2x plus 8, right? So what do you want to do here, right? First, you want to distribute that 3. Bam, bam. So now what do I have? I have 3x plus 6 minus 4 is greater than 2x plus 8. Next, you want to combine like terms, right? Combine like terms. Fancy way of saying add, right? So what's 6 minus 4? 2, right? So now I have 3x plus 2 is greater than 2x plus 8. Again, I want to put all my x's on one side, all my numbers on the other. All right, so I'm going to subtract 2x from over here. What I do to one side of the inequality, I have to do to the other side of the inequality. So I'm going to subtract 2x from over here. Right? I'm going to subtract 2 from over here. What I do to one side of the inequality, I have to do to the other side of the inequality. I'm going to subtract 2 from over here. So what do I have? 3x minus 2x is 1x, right? Bring down the inequality, greater than. What is 8 minus 2? Sorry. Hey, we good, man. What's 8 minus 2 real quick? Very good. So there you go. This is my answer right here. X is greater than 6, all right? But now that I found my solution, right? I want to graph it. All right, so let's graph it. You got the top part already? You got it? All right. So now I want to graph it, right? So I'm going to make a number line. In the middle, I'm going to write 6 just to make things easy. Now, you know, everything to the right of 6 is going to be bigger, right? So we're going to have what? 7, 8, 9, 10. You get the idea, right? And everything to the left of 6 is going to be smaller, right? So we're going to have like 5, 4, 3, 2. You get the idea, right? X is greater than 6, right? So greater than 6 means I'm going to have an open circle, right? And then which numbers are greater than 6? What is it? Right. To the right, right? The numbers to the right. So you're just going to shade these in. And that's it, right? If you don't want to use the open circle, right, you could use the parentheses, your choice. You could say it like this as well. All right, up to you what you want to do. You want to do open circle? Fine. You want to do the parentheses? That's fine too. And then you just shade to the right. Questions on this? All right. Like I said, like I accidentally posted this homework already in early March, so y'all could be doing that, huh? Say it again? No, not yet, not yet. No. Yeah, so I didn't even make the answer key to be honest with you. I've just been busy the past couple of days. Yeah. 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 Yeah, it's all good. It's all good. All right. Remember that tomorrow y'all got tutoring also? Huh? No, no, I mean in class tutor tomorrow. Yeah. No, but tutor's open today. Tutor's open today. I'm going after class right now. All right. All right. Anyway, test value method for graphing linear inequalities in one variable. Right? So here's how you do it. First, you find the border value by solving the corresponding linear equation. Determine which side of the border value to shade by choosing a test value and deciding whether it is a solution or not. Right? Represent the border value with an open or closed circle according to whether the inequality is strict or not. So when they're saying test value, right? Just to clarify on the video, right? What they're saying is we know that x is greater than 6, so you're gonna plug in a number that you know is bigger than 6, like for example 10, right? And then you're gonna ask yourself, which side is 10 on? Is 10 on the right of 6 or is 10 on the left of 6, right? It's on the right, so you know that that's the side that you're gonna shade, right? That's what they mean by test value. You just pick a number, you test it, you know. Here's another example right here. Oh, my fault. You still copying? You got it? You got it? All right. Oh, sorry, brother. I don't know what that was. All right. Try this out. Try this out. Literally the same question. You know, little math, boom, boom, boom. Put all your x's on one side, put all your numbers on the other, then graph it. All right. Go ahead. For it, right. To, distribute the two. So we're gonna multiply, yeah, 4x and then minus 2. All right, how we looking? We good? Want to go over it? Or do we need another minute?
Your answer. Following from what part of the country framework is you are in New York City to need to put together some the itinerary that include a list of things to complete time for each. And it would say mileage, just a way to roll the contents or out. What is your answer? What should be your answer?
I think it's the output. What class is this?
Output.
Yeah, what class is this?
That's uh, it's about one.
Which one?
Uh, I don't know.
All right, finish it.
What
I think it's the output.
how
Yeah. Oh, go ahead. You do it.
how almost done in your homework.
Good, good. So,
And this is this right. Uh, you'll be showing them this right Elaine's question.
yeah. No. The other inequalities.
Inequalities.
Yeah. My fault. I posted it too early.
It's okay. Which one? Inequalities. Line solving linear equation. So, you see,
Yeah. Good job.
I made it.
Yeah. All right, let's go over it. All right. So let's recap what I have. I have 2 times 2x minus 3 plus 3x less than or equal to 10x minus 5. All you have to do is distribute the 2 first. So 2 times 2, that's going to give me my 4x, minus 2 times 3, which is 6, plus 3x, less than or equal to 10x minus 5. Now let's combine like terms, right? It's a fancy way of saying add, right? So 4x plus 3x is 7x, right? So I have 7x minus 6 is less than or equal to 10x minus 5. Now, again, I want to get all my x's on one side, all my numbers on the other, all right? So I'm going to subtract 7x from over here. But you know what I do to one side of the inequality, I have to do to the other side of the inequality. Subtract 7x from over here. I'm going to add 5 over here. But you know what I do to one side of the inequality, I have to do to the other side of the inequality. So now negative 6 plus 5 is what? What's negative 6 plus 5? You can use your calculators. You don't got to do it in your head. Huh? Negative 6 plus 5. What is it? Say it again. Negative 1, right? Oh, no. You good. You good. Yeah. No, you good. You good. All right. What about what's 10x minus 7x? 3x, right? But now again, I want to get all my x's on one side, all my numbers on the other. So I have to get rid of that 3. How do I get rid of the 3x? Excuse me. How do I get rid of the 3? Not the 3x, the 3. Right. I'm going to divide by 3 over here. But what I do to one side of the inequality, I have to do to the other side of the inequality. So now, what's my answer? X, read it backwards, is greater than or equal to negative 1 over 3. Questions on this? Good? All right, go ahead. Take your time. Take your time. My next step after this is to graph it. All right? It's going to be my next step. That's your groceries? Groceries. They got it downstairs. Got you. All right. Taxi tomorrow. Yeah. Huh? Well, we gonna get back to that. Yeah, 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 yeah. So we already did do a transition like to chapter seven, right? But there's a idea in chapter seven that I want y'all to understand. It's this inequality stuff. You know? You good? So now I want to graph this. So what am I gonna do? I'm gonna make a number line. I know my number line ain't straight. I have trouble drawing straight lines. That's why I didn't major in art. All right. But best believe if I go to an art gallery and the line ain't straight, I'm gonna critique that artist and be like, yo, your line ain't straight. All right. So I have negative one third right here. Right? Just write that straight in the middle. Now to my right, right, I'm gonna have numbers that are bigger than negative one third, right? Bigger than negative one third. I'm thinking like here goes zero, here goes one, here goes two, here goes three. You get the idea, right? To the left of negative one third, I'm going to have numbers that are smaller than negative one third. I'm thinking about like negative one, negative two, negative three. You get the idea, right? Okay. This is greater than or equal to, so I'm going to do either a dark circle or I'm going to do a bracket. I kind of like the brackets myself. I'm a bracket person, right? So here goes my bracket. And I want the numbers that are bigger, greater than or equal to negative one third. So those are all the numbers to the right of it. And that's it. That's the graph. If you did a closed circle, that's still correct. That's all right. No problem. Any questions on this? Homework is already posted. Just letting y'all know. Danny just showed it to me. It was only like 6 questions, so it's not that much. Or was it 8? I don't know. I didn't count. So we good? All right, let's do another example. Go ahead, try that out. Same thing. X on one side, numbers on the other, graph the answer. That's it. All right, we good? All right, let's try this out. So I got 4x minus 7 is less than 2, right? So I'm going to add 7 over here to get all my numbers on one side. But you know what I do to one side of the inequality, I got to do to the other side of the inequality, right? So now what do I have? I have 4x is less than 2 plus 7. What's that, like 9 or something? But I still got that 4. That's an issue. How do I get rid of this 4 in front of the x? Divide, right? So I'm going to divide the 4 by 4. But you know what I do to one side of inequality, I got to do to the other side of inequality. So now what do I have? I have x is less than 9 over 4. All right. Now what do I got to do after this? I got to make a number line. Remember, our answer is a graph answer, right? So just put the 9 over 4 in the middle, right there, right? So then now we're going to do numbers to the right of 9 over 4 and numbers to the left of 9 over 4, right? So what's to the right of 9 over 4? Let's say like 3. Then we have 4. Then we have 5. Then we have 6. You get the idea, right? All right. How about to the left of 9 over 4, right? How about 2? How about 1, 0, -1? You get the idea, right? The numbers to the left are getting smaller, the numbers to the right are getting bigger. That's it. All right. Now this is less than 9 over 4, so we could do an open circle. You could do a parentheses also if you want, no problem, right? And then you want the numbers that are smaller than 9 over 4, so those are the numbers to the left. And that's it. Let me give you guys a little bit of a hint too, right? Notice how the inequality symbol right here, notice how that this thing kind of looks like an arrow, right? Low key, it looks like an arrow. Forget about reading about it. Just kind of looks like an arrow. What what side is it pointing to? The left side or the right side? What would y'all say? To the left side, right? And notice how that's the side that I shaded. I don't know if that helps, but that's a little hint that y'all could use. All right. All right. This sounds good. Let's keep it moving. So now we're going to talk about solving linear inequalities in one variable standard form method, right? Standard form method. Another way of deciding which half of the number line to shade for a typical linear inequality in one variable is to take advantage of the form x less than whatever or x greater than whatever. We will call this form the standard form, in which the variable appears on the left side of the inequality by itself with no operation. We open this section by considering an example of this form. X is less than or equal to 2, right? The graph consisted of shading all the values less than to the left of 2, along with the border value 4, which we indicated with the solid circle. There you go. All right. So we have our border value of 2, solid circle, shaded it to the left. Right. On the other hand, we considered it the inequality x greater than -3, also in standard form. The graph consisted of shading all the values greater than to the right of -3, with the border value -3 indicated with an open circle to indicate that it is not a solution of the inequality. All right. All right, just to show y'all what that is. There you go. This is for x greater than -3. We have -3, our border value, which is with an open circle, and we're shading it to the right. All right, that's x greater than -3. All right. Our second method of solving linear inequalities in one variable will be to convert the inequality into an equivalent one in the standard form with the variable by itself on the left side of the inequality in almost exactly the same way we did to solve the linear equation. In that case, we can follow the rules. For inequalities in the standard form, x is less than or equal to a or x is less than a, always shade to the left of the border value of a. For inequalities in the standard form, x is greater than or equal to a or x is greater than a, always shade to the right of the border value of a. All right. As usual, the border value a will be indicated with a solid circle or an open circle, depending on whether or not the inequality is strict. All right. The standard form method has the advantage of the word always in particular. Because we take the trouble to write the inequality in the standard form, there is no need to choose a test value to determine which side of the border value to shade. There are two important points that need to be kept in mind, however. The first is that the standard form presumes that the variable is by itself on the left side of the inequality. When we solved equations, we were free to write the variable by itself on either side of the equation. In fact, we saw examples where it was more convenient to write an equation in an equivalent form with the variable by itself on the right side of the equation. This problem is easy to solve as long as you keep in mind that writing a less than b is exactly the same as writing b greater than a. So you can read the inequalities backwards. That's what it's trying to say, right? You can read them backwards. If the x appears on the right, just read it backwards or flip it around. It's another way of saying it, right? In other words, writing the inequality from right to left changes the sense of the inequality. In other words, the inequality symbol points in the opposite direction. So if we were to rewrite a linear inequality of the form 5 greater than or equal to x, we would simply rewrite it in the standard form x is less than or equal to 5. It means the same thing, right? You guys saw me do that earlier. The second point to keep in mind is more serious. The careful reader might have noticed that this method was described as rewriting the inequality in standard form in almost exactly the same way as a linear equation. More specifically, that means using the addition and multiplication principles to do the same thing to both sides to obtain a simpler statement. In fact, the addition principle can be used in exactly the same way, adding or subtracting the same quantity from both sides of the inequality produces an equivalent inequality, an inequality with the same solutions. All right. The multiplication principle requires some adjustment, however. To see this, let's start with a true inequality. 2 is less than 3. Multiplying both sides by 5, for example, we obtain the inequality 10 is less than 15, which is still true. However, pay attention to this. However, if we multiply both sides of the same equality by -5, now we have -10 is less than or equal, is less than -15, which is false. It's not true. -15 is smaller than -10. So clearly, multiplying and dividing, as you might guess, by a negative quantity has a different effect than multiplying or dividing by a positive quantity. Without going into a lengthy explanation for why this is so, just keep in mind that multiplying by a negative quantity involves in some sense of an opposite. So and additive opposites on the number line are mirror images of each other reflected across the point representing 0. For this reason, we need to adjust the multiplication principle for inequalities. So here it is. The multiplication principle for inequalities. Multiplying or dividing both sides of an inequality by a positive quantity will produce an equivalent inequality. Multiplying or dividing both sides of an inequality by a negative quantity, this is the important part, by a negative quantity will produce an equivalent inequality after changing the sense of the original inequality. When you multiply or divide by a negative number in inequalities, you flip the sign. That's what it's trying to say. All right. So let's take a look at an example. So for example, dividing both sides of the inequality -3x greater than 6 by -3 gives the equivalent inequality -3 divided by -3x divided by -3, that cancels out. And then 6 divided by -3 is going to be x. But instead of x less than -2, you're going to flip the sign, right? The sense of the original inequality has changed from greater than to less, from greater than to less than. With these two small adjustments, our method of approaching linear equations, let's go back to the same examples we saw in the test value method. So let's look at this real quick. I'm just going to do this real quick just to save time, right? So we have 3 times x plus 2 minus 4 greater than 2x plus 8, right? First, you distribute out the 3. So we're going to have 3x plus 6 minus 4 is greater than 2x plus 8. Let's combine like terms. It's a fancy way of saying add. 6 minus 4 we know is 2. So this is 3x plus 2 is greater than 2x plus 8, right? So now, right, let's say that I subtract 3x from over here. What I do to one side of the inequality, I have to do to the other side of the inequality. Let's say I subtract 8 from over here. What I do to one side of the inequality, I have to do to the other side of the inequality, right? So now 2 minus 8 is what? -6, right? Greater than 2x minus 3x is -x, right? Now I got to get rid of that negative sign, right? So how do I get rid of the negative sign? I'm going to divide by -1. But what I do to one side of the inequality, I have to do to the other side of the inequality, divide by -1. Because I'm dividing by a negative, I have to flip that sign. So -6 divided by -1 is +6. Instead of the greater than, this becomes less than and an x. So 6 less than x. Read in reverse, this becomes what? X is greater than 6. Right? So that's how that's how this works. Again, after you get the answer, little number line, you already know this is 6, 7, 8, 9, 5, 4, 3. You get the idea, right? This is going to be a open circle or parentheses. I'm going to use a parentheses, and we're going to go to the left. I mean, to the right, excuse me. I'm going to go to the right. All right. And of course, open parentheses, I'm not including 6. Questions on this? The lesson here, when you divide or multiply by a negative with inequalities, you flip the sign. Okay. The original question? This part? Huh? Like the paragraph part, this? Go up? Oh, this part. That one? Got you. Mm-hmm. I got you. You good? Sorry, keep going, keep going. Got it? Right. Mhm. Good. No, no. Whenever I divide by a negative or multiply by a negative. So right here. Down here. Instead of saying 6 is greater than X, I said 6 is less than X. And then I read it backwards and flipped it around. And then the graph, all that good stuff. All right. All right, so let's summarize the standard form method. So the standard form method for graphing linear inequalities in one variable, you use the addition principle and modify the multiplication principle to rewrite the inequality in the standard form with the variable by itself on the left side of the inequality. For inequalities involving less than, right? So less than or less than or equal to shade to the left of the border value. For inequalities involving greater than, right? So greater than or greater than or equal to shade to the right of the border value. All right. This represent the border value with an open or closed circle according to whether the inequality is or is not strict. All right. So let's apply this method to the other two examples we saw previously. So here's another example. Graph all the solutions of the inequality. Try that out. Give y'all like a minute to do that. All right, let's go over this real quick. I have 2 times 2x minus 3 plus 3x less than or equal to 10x minus 5, right? First thing you want to do, distribute that 2. So now I have 4x minus 6 plus 3x less than or equal to 10x minus 5. Combine like terms. Now I have 7x minus 6 less than or equal to 10x minus 5, right? I'm going to subtract 10x from over here. What I do to one side, I got to do to the other. I'm going to add 6 over here. What I do to one side, I got to do to the other, right? So now 7 minus 10x is close. Give me a better answer. Yeah,
Negative.
negative 3x, right? Less than or equal to. What's negative 5 plus 6? 1, right? So just 1. So now I want to get rid of that negative 3. So I have to divide by negative 3. But what I do to one side of the inequality, I have to do to the other side of the inequality. All right? So what's my answer? Somebody tell me.
X greater than,
Greater than or equal to
yeah,
negative 1/3.
over.
Very good, right? Because I divided by the negative, I have to flip the inequality, right? So instead of less than or equal to, it becomes greater than or equal to. After that, make your number line in the middle. Huh? Yep, that's it. That's the only rule. You have negative 1/3. Numbers that are bigger than negative 1/3, let's say like 0, 1, 2, you get the idea. Negative numbers smaller than negative 1/3, let's say negative 1, negative 2. All right, you get the idea. This is gonna be, I'm gonna use the bracket this time, right? I'm gonna use bracket. So we have our open bracket, and we're greater than or equal to, so we're gonna be shading to the right. And that's it. Scroll up. Right here. Yeah. You did the other way. You put on the other side. That's fine. As long as we get the same answer, we good. We good. Yeah, I got you. Yeah. Yeah. At the end of the day, as long as we have the same answer, I'm happy. Good. Mhm. Good. All right. All right. Try this out. I'll give y'all like 2 minutes for that. Phew. Excuse me. Thank you. Thank you.
So in this I need to multiply 4 times 7. No, no.
Move the numbers to the other side and leave X by itself. Yeah. Mhm. Yeah. Because I gave you the homework too early. That's why. Mhm. But yeah, tomorrow we'll get a new topic y'all never seen. Mhm. But it's gonna involve this idea. So for now, tonight, there's no new homework. Just do what you can to catch up. Just to let y'all know too, Remember, y'all have pantry. Y'all can go after class. I'm going to tutoring after class. There's a movie on the quad tonight, right? I don't think it's gonna start at 6 because it still looks pretty bright outside. But whenever the sun goes down, they're gonna set it up, and then you guys go out and watch a movie if y'all want. They'll have snacks there. All right. On the quad, like so, you know that grass area in front of like Meister or Roscoe Brown or whatever. Is that area? That's where they're gonna have it. Like, huh? Outside, yeah, yeah, yeah. So that's tonight. You already know pantry's going on. Y'all could go downstairs and grab y'all snack and or your groceries. I didn't check my email, so I'm not sure what else is happening tomorrow. But y'all know the drill, right? There's probably something going on in either Roscoe Brown or the library or Poston Hall. Just go and enjoy yourself. Grab a snack.
So in this case, I can't do four. What I do once I think first, I do it the other side.
Right.
So four, then you can we do it.
Yep, we're gonna do it right now. So I got 4x minus 7 is less than 2, right? So I'm going to add 7 over here. What I do to one side, I got to do to the other. So now I have 4x is less than 9. And now I want to get x by itself, so I'm going to divide by 4. What I do to one side, I got to do to the other. All right? So now what's my answer? X is less than 9 over 4, right? Because the 4 is positive, I don't flip it. And then now, we'll do a little number line. Got the 9 over 4 right here. So to the right of that, let's say we have like 3, 4, 5. You get the idea. To the left of this, let's say you have 2, 1, 0. Okay, you get the idea. It's less than, right? So I'm going to use a parentheses and just shade to the left. And that's it. It could also be an open circle too. That's fine as well. Questions on this? We're good? All right. All right. So in closing, to summarize, a typical linear inequality in one variable will have infinitely many solutions. For this reason, the solutions are typically indicated with a graph on a number line. The typical graph of a linear inequality will be half of a number line, all points to the left or to the right of the border value, with the shaded region representing solutions to the inequality. The border value is indicated with either an open circle, right? In the case of a strict inequality, less than or greater than, or a solid circle, right? Solid dot, in the case of a non-strict inequality that's less than or equal to or greater than or equal to. All right. Which side of the border value to shade can be determined either by the test value method, so you plug in a number and see which side it's going to go, or by the standard form method, solve for x. Easiest way, just solve for x. All right. Keep in mind that the inequality, like an equation, can be, sorry about that, can be an identity, and so all real numbers are solutions, or a contradiction, and so has no solutions. All right. That's it for today. Y'all free to go. Come sign attendance though before y'all leave. Can I take this down? Is anybody still copying? I can take this down. All right, appreciate y'all.